The last part of the section dealing with ionic bonding, we're going to look at a couple of very short things. Number one, lattice structure. In ionic bonds, they're not discrete molecules. It's not like if you have a bunch of salt, it's not like a salt crystal. You do not have like a handful of M&Ms. That each one is a separate NaCl. It is a big, um, massive continuous structure of sodiums connected to chlorines, connected to sodiums, connected to chlorines, and so on and so forth. So when we talk about a formula unit, we're talking about a chunk of those NaCls that give us, well, what is the simplest whole number ratio? And again, there's various pictures in the book of, well, you got an Na connected to a Cl, connected to an Na, connected to a Cl, and so on and so forth, and that just continues. Well, what we know is, well, the ratio of NAs to CLs is 1 to 1. That's what we're most concerned about. So they briefly talk about that. So then we talk about lattice structure. Well, what is the lattice energy? The definition of lattice energy is really the strength of the bond. How do we actually calculate this? Well, and again, we will spend more time when we talk about energy and bonds, bond energy later on. But basically what it is, it's the energy released when 1 mole of gaseous ions form a solid compound. So what we're basically saying is if we have a positive ion that's gas, react it with a negative ion that's a gas, and they form a solid compound, energy is also going to be released. Okay, so energy is released, exothermic. That's all really we're going to talk about lattice structure and lattice energy now until we get into bond energy. All right, the second item, again, fairly quick, is they very briefly talk about the differences between ionic and covalent bonds on page 193. So we're comparing the different bonds. What are the properties, characteristics, things like melting point, boiling point, bond energy, and a few other things. Not a long list, it's a fairly short list, but a few very distinct and important differences between the two. All right, the last thing then, polyatomic ions. Well, we briefly talked about these in covalent bonds. So this is the last part that kind of ties um, polyatomic ions with covalent bonding, ionic bonding. So if you remember when we did polyatomic ions, we briefly talked about them in covalent bonds. So what they are truly a covalent structure that had to have extra electrons added or lost so that they could share the electrons and be a stable compound. Now what happens is then that polyatomic ion then combines with other ions to form an ionic bond. So we are used to a sodium atom bonds with a chlorine atom to make NaCl. Well, now what we're saying is, well, maybe a sodium doesn't bond to a chlorine, but it bonds to some multiple atom ion that's negatively charged. And the exact same thing applies, except instead of it just sodium bonding to just a chlorine, it bonds to a structure that has several atoms with it. It's the same principle. It's still opposites attract positive negatives, but it's just that that other structure is not a single atom like chlorine, but a polyatomic ion. Here are ones that we would have seen. We drew some of these in section 2, the covalent bonds. So we've got NH4 plus. So NH4, we could draw its covalent structure. Okay, it has covalent bonds in it. But then what happens is it can ionically bond with a negative structure. So not only could we have Na bond with Cl to make NaCl, we could also have NH4 plus bond with Cl to make NH4Cl. We treat it exactly the same way. The difference is this entire structure is a positive charge, and that entire structure is a positive charge. We treat it exactly the same way. The other thing, we talked about, where did this extra electron go in NH4 when we drew its structure in section 2. Well, where did it go? It went to a chlorine ion, a chlorine atom that wanted that extra electron to become negative, therefore it would be stable. Now, we look at SO4 2 minus. Well, let's say we bonded sodium, which is a +1 charge, with sulfur, which is a 2 minus. Okay, same thing as oxygen, it's a P4. Well, what's going to happen here? Well, it's going to take 2 sodiums to bond with that 1 sulfur, right? +1 charge, -2 charge. Well, sodium then could also bond with a multiple atom, a polyatomic ion. So let's say it could bond with an SO4 structure that together it has a 2 minus. What happens here? Same exact principle. 2 sodiums are needed to bond with that ion, that polyatomic ion. So we could go through here and treat everything exactly the same way, whether or not it's a single atom ion that's positive or negative, or a polyatom ion that's positive or negative. The ionic bonding still occurs the same way. Opposites attract, charges have to cancel out, pluses, minuses, everything's got to equal 0. Okay? And this is what we're looking for as we do this. We will spend a lot more time when we get into 7.1 in terms of naming these and drawing these. All we want to see now is how this bond can happen. And our concern is we know positive and negatives attract, and therefore we get an ionic bond. So, like I said, we will continue more of this once we get into chapter 7 and talk about nomenclature and how we name these structures.